Okay, so here, let me just tell you a keywords here. The keyword is see, its mass is leaking by 4.1 gram per minute. So that means the rate, which is the slope, is negative here. So if I write, okay, so X is representing the number of minutes and the Y is representing the mass. So then when I write this, I'm going to write Y equal to mx plus b, the slope-intercept form. Y is representing the mass and X is representing the number of minutes. So it's leaking 4.1 gram per minute. So I'm going to put here negative 4.1 X plus b. Like I said, this is going to be the slope rate, and this thing is the rate. Now, after 8 minutes, right, after 8 minutes, then the remaining gas is this much. So this is going to be my X value. This is going to be my Y value. So basically, I have this point. I have 155.8. Okay, that's what this is, right? 155.8. Okay, now I'm going to plug that in. So this is X, this is Y, to find the Y. So this is 155.8 negative 4.1 times 8 plus b. Now let's do this algebraic here. So I'm gonna have to use my calculator here. So I'm gonna do 41 times 8. 4.1 times 8. That's 155. This is negative 32.8 plus b. Then I'm adding 32.8 to both sides. 0.8 to both sides. So that's plus 155.8, which is 1 equals 188.6. Okay. So then I'm putting here, so now my equation is this, y equal to negative 4.1 x plus 188.6. So that's what I'm going to put here. I'm going to put here y equal to negative 4.1 x 188.6. Okay, that's part A. Part B says 37 minutes after the experiment started, 37 minutes after the experiment started, there will be how much gas left. So then this is your X value. So you're just going to plug that in here. This is your equation. Now, for any number of minutes, you will find the amount of gas. Okay, so y equal negative 4.1 times 37 plus 188.6. So let's just go ahead and compute that. And that will be, okay, 4.1 times 37. Okay, and then that's actually negative. And then we'll do plus 188.6. So if you put this in your calculator, you're going to see this 36.9. So this is what's left. This is 36.9. Okay. If this linear model, now for number C, if this linear model continues to be accurate, I guess after how many minutes, right, since the experiment started, all gas contained will be gone. So basically we want the Y to be 0, right? If I want all the gas to be 0, to be gone, then I need Y to be 0. And what is the corresponding number of minutes that gives me Y equal to 0? So I'm going to make Y 0. So let me do that here, C. Okay, so this part was just a B. This is part B. Now part C is, I'm going to make Y 0. The equation, right? Take the equation and make Y 0. So then you have 0 equal to negative 4.1x plus 188.6. And then add 4.1x to both sides. And then divide both sides by 4.1. Cancels out. So x equal to now 188.6 divided by 4.1. And that equals 47. So basically, I'm sorry, 46. So 46 minutes. And your answer here will be 46 minutes. After 46 minutes, all gas will be gone.